So to determine the equation of the line, we have looked at previous lessons already, and we know that the equation of a line is y is equal to mx plus b. That's the equation of a linear function in general. And to be able to write this equation, we need two things, as we looked at before. We need the slope and we need the y-intercept. The slope is equal to the rise divided by the run, which is equal to the change in your y value, the vertical change, divided by the change in the x value, the horizontal change. So to be able to then write a function, a linear function, all we need to do is figure out the slope and know what the y-intercept is. And we've done some of these before. So here's one example. The line has a slope of 1/3 and a y-intercept of 4. What is the equation of the line? And just a reminder, that would be y is equal to 1/3x, and 1/3 is the slope. That's always the coefficient of the x value, plus 4, which is the constant term for the y-intercept, the constant term b. And so this is the function that has a slope of 1/3 and a y-intercept of 4. Now let's look at the second example. And in the second example, I have a line that goes through some kind of a point and has this slope. So I already know that this is going to be the coefficient of x. The 2 is going to be the coefficient of x. But what about this point? How can I use this point? And here's something that we haven't seen before. We want to use a point and the slope to figure out the equation of the line. So let me just write down the equation of the line again. That's y is equal to mx plus b. I know that this is 2, so I have m, but I don't have b. But here's what else I have. I have a specific point. And with this point, I have an x value and I have a corresponding y value. Remember, if I put my x value into an equation and I calculate that side, I get my y. Well, that's what I have here. I have an x value with a corresponding y value. And I have a slope. So, if I use my function here, I have x, I have the y value, and I have a slope. And so what I end up, if I insert all of these, if I substitute all of these, I will end up with 1, 2, 3 knowns and 1 unknown. And that's all you need to be able to solve for the unknown. And what happens as a result is you will find out what the b value is, and then you know what your m value is and what the b value is. And that's all you need, as I mentioned before. Those are the only things that you need to write the function. So my goal is insert x is equal to 1, y is equal to -3, and m is equal to 2. Insert that into the function, and you get the following. -3 is equal to 2, slope. X is 1, so 2 times 1 plus b. X is 1, m is 2, and y is -3. Now, I can solve for b, but before I solve for b, let us simplify everything that we can here. So what that means is if you can multiply numbers together, multiply it, and if you can combine numbers together, do that first before you solve. So here you can see that 2 and 1, this multiplication, I can multiply those two together before I start solving. And that's all I can do. So I will just multiply 2 by 1, which gives me 2 plus b. And now I need to solve for b using inverse operations. And there's only one operation here on the side of b, and that is a plus 2, a positive 2. Okay, and so to get rid of this positive 2, I would have to subtract 2 on both sides. When I subtract 2 on both sides, on the right-hand side I will be left just with b, and on the left-hand side I will be left with negative 5. So let me come back here again. This was my goal. I wanted to find out what b was, because now I have the slope of 2 and I have a y-intercept of negative 5, and that means that I can now write my equation. But remember, your equation does not need to have the x and the y values in there. It needs to have them as variables, so that you can use them for different x and different y values. So your equation is going to be y is equal to mx, which is 2x, plus b, but the b value is negative 5, so minus 5. There is my equation. Y is equal to mx plus b. Now you can do this graphically as well, and you will have to be able to do both, graphically and algebraically. To do this graphically, what we will do is we will plot the point, and using the slope we will get to our next points. So let me start by drawing the graph first. Here's our Cartesian plane. We'll start by putting the point in, 1 comma negative 3, and that is right here. Now we will use the slope of 2 to get to my next point, and remember that the slope of 2 means that you have a rise of 2 and a run of 1. So to get to my next point from here, I will have to go up by 2 and right by 1. And I will get to the point 2 comma negative 1, up by 2 to the right by 1, and I will get to the point 3 comma 1, and so on. Now if you want to, you can work your way backwards as well, and you will find out that you will end up at this point, but you can also just use a line to see that you would end up at this y-intercept right here. And that y-intercept is 0 comma negative 5. And this value right here, the negative 5, that is my y-intercept. And those are the only two things that I will need to figure out what my equation is, or to write my equation. The y-intercept and the slope. And so here's my function again. Y is equal to the slope times x, which is 2 times x, plus the y-intercept, which in our case is negative 5. So plus negative 5, which is the same thing as minus 5. And so that's how you can do this graphically. So what did we do? Let's go back to the algebraic version and just reviewing this very quickly. We had a point and a slope. I put the slope into the function, and I also inserted the x and the y values of our point into the function, which left me with only one variable, which I can solve for, which I can determine using the other ones. And once I have that, I will write my general form of the equation using only m, the slope, and b, the y-intercept.